What's the most powerful invention in human history? The wheel, fire, language? Wrong. It's literally nothing. The number zero. Jan 628 Common Era. It's twilight, pre-dawn. A 50-year-old astronomer climbs stone steps to an observatory tower. His name is Brahmagupta. But this morning, he's not looking at the stars. He's looking at the space between them, at what isn't there. And in that absence, in that void, he's about to give the world something it has never properly possessed. A number for nothing, zero. I'm Sarvajit, and this is a story of how one man in 7th century India invented zero, formalized negative numbers, and built the conceptual foundation for every computer, every spacecraft, every algorithm on Earth. Welcome to India's Golden Age podcast. Subscribe now to hear fascinating stories like that of the man who gave the world nothing and changed everything. But to understand why zero was revolutionary, we need to see the world without it. Roman merchants in 350 Common Era needed an abacus to multiply. MCMXC5 into DCCL12 is a nightmare. Indian merchants at the same time, the Gupta Golden Age, did compound interest in their heads, including a dot for empty space, the zero. Earlier, Aristotle declared,
Nature abhors a vacuum.
so greed never got zero. No algebra, no zero, but across the mountains, along the Indus and the Ganga, Buddhist monks meditated on Shunyata. Upanishads explored Neti, Neti, not this, not this. Emptiness wasn't scary, it was sacred. And into this climate, a boy is born in Bhilamala, modern day Bhinmal, Rajasthan. His name is Brahmagupta. And the boy will complete what centuries of Indian mathematicians started. Before we meet Brahmagupta properly, we need to meet others whose work made his revolution possible. First, imagine a merchant's daughter. Let's call her Nagasena. She's educated amongst other things in accounting. She uses a system, dhana and rina, fortune and debt. Nagasena doubles as part-time accountant for her rich merchant dad. The language of mercantile accounting was often maintained by women while men travelled and traded. When monsoon rains fail and farmers default, Nagasena asks her merchant father not to panic. Nagasena calculates. She tracks negative balances, spreads her risk across multiple clients. Her competitors, still using simple tally marks, lose everything. She not only survives, she profits. Sometime later, young Brahmagupta will fall in a forbidden love with Nagasena. Observe Nagasena's methods. He'll realize mathematics, it's how merchants survive. Those dhana, rina metaphors he'll make famous. Zero wasn't invented by one genius. It was used by working people, merchants, farmers for centuries. So what was great about Brahmagupta's achievement? He theorized it. He made the informal formal, the procedural philosophical. Every piece of digital code now runs on 0 and 1. The year is 628 Common Era. Brahmagupta is 50 years old, head of the Royal Observatory in Ujjain, the Greenwich of ancient and the medieval world. He writes the Brahma Sputa Siddhanta, the correctly established doctrine of Brahma. The book is primarily an astronomy text. Planetary motion, eclipses, predictions, festival date calculations. But in chapter 18, almost as a afterthought, he drops a revolution. Listen to his words translated from Sanskrit text.
Zero is added to a number or subtracted to a number. The number remains unchanged.
Simple, perhaps, but no one had formalized this before. A number multiplied by 0 becomes 0. And then the truly radical part. He addresses negative numbers.
A debt minus 0 is a debt. A fortune minus 0 is a fortune.
He uses economic metaphors, dhan, credit, and rin, debt. This isn't abstract symbolism, it's accounting.
The product of two debts is a fortune.
Negative time negative equals positive. To modern day 6th grader, this is memorized tedium. But in the 7th century Common Era, this is cognitive sorcery. How can two absences create a presence? How can multiplying two debts produce wealth? The answer lies in the logic of opposites. If you owe someone who owes you, your debt's cancelled. Brahmagupta saw this pattern and he formalized it. He made it universal. Brahmagupta made his only major mistake when he attempts to divide by 0.
What is a number divided by 0?
A fraction, khacheda.
5 centuries later, Bhaskara too will correct him. Division by 0 yields an infinite quantity, says Bhaskara. Closer, but still not quite right. Division by 0 is undefined. Cut to 820 Common Era. Nearly 200 years after Brahmagupta's death, we are in Baghdad, the house of wisdom. A scholar named Muhammad ibn Musa al-Khwarizmi encounters Brahmagupta's work and he's stunned. The Indian numerical system, 10 symbols including 0, is vastly superior to anything the Arab world uses. Khwarizmi writes Kitab al-Hisab al-Hindi, literally the book on Indian calculation. The word algorithm comes from al-Khwarizmi's name. The word algebra comes from his other book's title. Now we move to a few centuries later, in 1202 Common Era. Leonardo Fibonacci returns to Italy from North Africa. He's learned the new system from Arab traders. He writes Liber Abaci, introducing Zephyrium from Arabic Sifr, from Sanskrit Shunya to Europe. This becomes 0 later. Fibonacci brought 0 to Europe, but Europe banned it, calling it infidel math. But efficiency of Arabic maths is undeniable. Calculation that took hours now take minutes in infidel maths. By the Renaissance, Indian mathematics, rebranded as Arabic, starts dominating in Europe. By the scientific revolution, they enabled Newton's Principia, Leibniz's calculus, Einstein's field equations. Without Brahmagupta, rules for 0 and negatives, there is no modern physics, no computer science, no device you're listening to this on. One astronomer in Ujjaini broke open the universe. So what does the 7th century astronomer's discovery of 0 teach us? Lesson 1. Narrative matters more than facts. Arabic numerals is factually wrong. Arabs themselves called the numbers Indian numerals. But Europe encountered them through Arab intermediaries and stopped investigating. India lost credit through linguistic drift and narrative laziness. Today, how many breakthroughs by Indian origin researchers get credited to Silicon Valley without mentioning IITs or Indian intellectual traditions? Ashish Vaswani's transformer architecture, the foundation of ChatGPT, is apparently a Google innovation, true. But Vaswani went to BITS Mesra in Jharkhand. That pipeline is invisible. Lesson 2. Infrastructure facilitates genius. Brahmagupta's ideas conquered the world because they were supported by a robust system. The Ujjain school, universities like Nalanda, manuscript culture, the patronage of kings, the trade routes through which books and ideas traveled. Modern India produces brilliant technologists, but it must build sticky intellectual infrastructure, world-class research institutes, domestic R&D spends, robust publication systems. Lesson 3. Humanities are foundational, not peripheral. Philosophical depth enables technical breakthroughs. India developed 0 because Buddhism and Hinduism embraced shunyata or emptiness. Greatest technological leap in history came from philosophical comfort but nothingness. You cannot separate innovation from worldview. The lesson, STEM-only education, is civilizationally suicidal. Brahmagupta's gift was existential as much as mathematical. He taught humanity how to measure what isn't there, proving that emptiness has structure, that gaps matter as much as what fills them. So what is 0 minus 0? Brahmagupta asked his students. The answer echoes across 14 centuries. 0. But now we know why. So if this story resonated, subscribe for more about how ancient India shaped us today. Want to go deeper? Explore my upcoming novel Dhruva Devi to experience the glory of the Gupta Golden Age. History isn't just facts. It's also the stories that define us. Stay curious and comment with how many marks you received in your maths exam in your class 10. Bye for now. Jai Hind.